Hi dear students, this is Hassan Korani. As I promised you, we are going to start a new chapter in this video about the scalar product of vectors in a plane. Usually in science we use scalar products of vector in physics, in mathematics. In mathematics usually we get the benefits of this of scalar products to calculate sides and angles in any triangles. Knowing the sides, let's say, of a triangle, we can know the angles, whatever the nature of this triangle. Okay, before we start the definition of scalar product, we need a necessary and an important concept, which is the geometric angle between two vectors. Let's see this simple definition. The definition of geometric angle between two vectors says that the geometric angle alpha between two vectors is the angle formed at their common origin. I think it's clear. Let's see an example on GeoGebra app. Suppose that we have a vector u and another vector v. Sure, they are not non-zero vectors. They have a common origin. They are placed at A. Their origins are at A. So the geometric angle between them, according to the definition, is this angle, which is alpha. Look, if we change all the position of v, we still have alpha. Be careful about this case. We don't consider the exterior angle. In fact, we consider always the interior angle. That's it. Okay, let's go back to see what do we have else. As you know, we have here title cases. As you know, we don't have usually the vectors drawn at the same origin. Sometimes we may have in exercises vectors with different positions. In fact, we are going to study these main four cases for position of vectors, relative positions of vectors. In the first case, as you see, we have vectors as we need. They have the same origin. In the second case, they have the same extremity. In the third case, we have the extremity of the first at the origin of the second vector. And in the last case, we have two vectors that are apart from each other. In the first case, if we are asked about the geometric angle between them, u and v, it's clear according to the definition, this is the needed angle. In the second case, we have vectors with the same extremity, and we are given the measure of this angle. We need to find the geometric angle between u and v, but we need them positioned at the same origin. In order to get this, we try to change the form, the position of u and v to get them at the same origin. To do this, we may, as you will see, we may slide u to get u prime and v to get v prime in a way that u prime and v prime are equal to u and v respectively. By this way, you can easily see that the geometric angle between u prime and v prime, since they have the same origin, is this one. And you can easily notice that this angle is equal to that by vertically opposite angle property, Thus, the geometric angle from the beginning between u and v, even if they have the same extremity, is also this angle, which is alpha. Okay, let's see the next case. Case 3, where we have a vector, the extremity of the first vector is placed at the origin of the second vector v. And we are given the angle theta. This is theta. Okay. We need them again according to the definition, placed at the same origin, and this is not the case, so we try to do what we have done in the case 2. If we slide vector u, let's say, and put its origin at the origin of v to get the needed angle. So this is the true angle, or the angle, geometric angle between u, or this u prime, and v, which is in fact, let's call it alpha, but we are given theta. And since you know this is a straight angle, then alpha will be 180 minus theta, or pi radians minus theta. Knowing theta, we can find the geometric angle alpha. Let's say, for example, if theta is 30 degrees, then the geometric angle between u and v is not 30. It's in fact 180 minus 30, which is 150. Okay, let's see the last case, which is where we have u and v are apart from each other. Usually in exercises, we may replace vector by another vector. Again, we slide one of them to put the origin of the second on the origin of the first by slide or draw a copy for v, let's say, at the origin of u to get v prime. By this way, we get two vectors of the same origin, thus the geometric angle between them is this one. You can see if we change v prime, which is equal to v, still at the origin of u, or you may slide or translate u and put it at the origin of v. As you see, again we get the geometric angle between these two vectors. Okay, the conclusion is to find the geometric angle between two vectors, we must have them drawn at the same origin to get this. Okay, let's see another cases. If we have, okay, we have a special case where we have collinear vectors. You know, two collinear vectors are either of the same sense, or of opposite sense. What if they are of same sense? What about the geometric angle between them? As you see, we have u and v placed at the same origin, and they are of same sense. You can see that the angle between them is 0. Why it's 0? You can see this. I started from 180, and I'm trying to have them of the same, having the same sense. At the end, you can see that the angle between them, geometric angle, is in fact 0. Sometimes they are positioned away from each other, but still they have the same sense. Even in this case, we can understand that the geometric angle between them is 0, and for this reason, as you see, we may translate v and put it at the origin of u, and we get the same previous case. So the geometric angle between v and u, even if they are apart from each other, is still 0, having them if they have the same sense. Okay. In the second case, if we have two vectors of opposite sense, okay, this is the case. They have the same origin, so according to the definition, the geometric angle between them is this one, which is clear, a straight angle, so it's 180. We can see this by making this animation. It's 180. In fact, once they have the same, they have opposite, sense. Even again, if we have the case of two vectors that are apart from each other, but of opposite sense, as you see, again, we can say directly that the angle between them is 180 for this reason, as you see, by sliding V and put it, or translating V and put it at the origin of U, and the angle between them again is 180. Clear? The last case, by this way, we will cover all the cases. The orthogonal vectors, two vectors U and V are orthogonal if their geometric angle is 90. Sorry. U and V are orthogonal, and we use this symbol to express the orthogonality of two vectors. Some people put a dash under this symbol, or simply like the perpendicular, what we use in perpendicular lines. As you see, we have vector U positioned here horizontally and another vector V, which is vertical. And we can notice that easily, the geometric angle between U and V is 90, so they are orthogonal vectors. We may have them in another position like this. If you see, we don't care about the sense of V and U. They have right angle between them, even if they are apart from each other. We say in this case that these two vectors are orthogonal. Okay, by this way, we covered all the cases of geometric angle. That's it. I'll give you a simple homework. Please try to practice it. Just pause this video and write all of these on your copybook and try to deliver me the homework. Okay, goodbye.